Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about derivatives. So we've started our journey in differential calculus. You may have heard the terms differential calculus and integral calculus. Differential calculus is the process of finding derivatives. Derivatives are the instantaneous rates of change of functions. So I want to get a little bit into the definition. We've seen this before in the previous two videos when we talked about slope of a curve and then instantaneous rates of change of a function. But it's the same definition. The limiting value of delta y over delta x as delta x approaches 0 is called the derivative of y with respect to x. And the general process of finding the derivative is called differentiation. So here's the definition and here's the notation that we use for derivatives. There's other notation which I'll mention shortly, but dy dx tells me I'm finding the derivative of the function y with respect to x, and that's defined as the limiting value of delta y over delta x as delta x approaches 0, and more specifically that's equal to the limiting value as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So this is what we've done in the last two videos, and we're going to continue that now with derivatives, exactly the same process. So let's take a look at some examples of finding the derivative of certain types of functions that you're probably going to be asked to differentiate. So in our first example, we're asked to find the derivative of this polynomial function. This is going to be a typical question that you're going to see when you're asked to find derivatives using the limit definition or the delta method. So what you usually will start with is defining f of x and f of x plus delta x. You can define those things at the side and simplify them first before plugging into your definition, or you can plug them straight into your definition. It's your choice. When you're finding f of x plus delta x, you're simply putting x plus delta x into the function wherever there's an x. So I'll have x plus delta x squared minus 3 times x plus delta x plus 4. When I expand all of this, I'm going to get x squared plus 2x delta x plus delta x squared minus 3x minus 3 delta x plus 4. So my derivative will be the limit as delta x approaches 0 of f of x plus delta x, which is this, minus f of x, which is this, all over delta x. In order to find this limit, we need to simplify because we cannot plug a 0 in for delta x. It gives us a denominator equal to 0, which is undefined. So in the numerator, I have x squared minus x squared. I have negative 3x minus a negative 3x. So negative 3x plus 3x gives me 0. In addition, I have 4 minus 4, which gives me 0. So I'm left with the limit as delta x approaches 0 of 2x delta x plus delta x squared minus 3 delta x. I can factor delta x out of the numerator, and then I can cancel the delta x to get the derivative equals the limit as delta x approaches 0 of this expression. I can now put a 0 in for delta x, and when I do that, I'm finding the limit, which would be 2x minus 3. So this is the expression for the derivative of this function. It's a lengthy way of obtaining it. In the next video, I'm going to show you how we can get this result very, very quickly without going through all of this work. But for now, if you're expected to use the limit definition or the delta process, this is the way you do it. Let's take a look at two other types of functions that you might be asked to differentiate this way. In the next example, the function is y equals 1 over x. So we know f of x is 1 over x, and f of x plus delta x is 1 over x plus delta x. So again, we plug into our definition, which hopefully you have handy, so you're not getting lost. dy dx will equal the limiting value as delta x approaches 0 of f of x plus delta x, so 1 over x plus delta x, minus f of x, which is 1 over x, over delta x. We need to simplify this before we can evaluate the limit by putting a 0 in for delta x. And there's different ways that you can simplify this. I'm going to do a bit of a shortcut that I talked about when I did a video on algebraic fractions. That shortcut is I multiply the numerator and the denominator by the lowest common denominator. So I'm going to multiply both the numerator and the denominator by x times x plus delta x. I'm not changing the value because I'm multiplying the numerator as well as the denominator by exactly the same thing. When I do that, when I multiply the numerator, remember that you're multiplying both terms, and when I multiply this fraction to this, the x plus delta x will cancel and I'll just be left with an x minus. When I multiply this term by this, the x will cancel and I'll be left with x plus delta x. And in the denominator, I will have delta x times x plus delta x. I'm going to simplify my numerator. I'm going to have x minus delta x. So x minus x is 0. So I will have negative delta x over that same denominator. Now I have a factor of delta x in the denominator and the numerator. So I'm left with a negative 1 in the numerator. This derivative will be the limit of negative 1 over x times x plus delta x as delta x approaches 0. Can I now put a 0 in for delta x? Absolutely. It does not make my denominator equal to 0. So when I put that value in, I will have x times x plus 0, which is simply negative 1 over x squared. That's the expression for the derivative of this function obtained by using this definition. Lots of work, and if you had problems with this, you're not having necessarily problems with calculus, you might be having problems with algebraic fractions, so you might want to go and take a look at, do a bit of a review on algebraic fractions. Let's look at one last example of a type of function that you might have to differentiate using this process. In this next example, our function is square root of x. Therefore, f of x plus delta x will be square root of x plus delta x. So we plug those into our limit definition to find the derivative. So it will be this f of x plus delta x, which is square root of x plus delta x, minus f of x, which is simply square root of x, over delta x. The strategy that you need to use so that you can simplify this expression so that you can find the limit is introducing a concept called conjugates. I don't want to talk about conjugates, I just want to talk about the strategy. What we can do here is multiply the numerator and denominator by the conjugate of our numerator, which means we just put a plus sign there. So we're going to do the same to the numerator and the denominator. Now remember, if you have a plus b times a minus b, that's going to be equal to a squared minus b squared. And we're using that concept with this. When I multiply this times this, I'm going to get square root of this squared. My outside term will be square root of x times this. My inside term will be minus square root of x times this, so they cancel each other out. And then I'll be left with minus square root of x squared. So I'm just using difference of squares. My denominator is this big mess. So my numerator will simplify. That will be x plus delta x minus square root of x squared is just x. Now in the numerator, x minus x is gone. So I'll have delta x over the denominator. The delta x cancels. Now I have the limit of a function that I can evaluate by putting a 0 in for delta x. When I do that, I get 1 over square root of x plus 0 plus square root of x. So I get 1 over 2 times the square root of x. That's the expression for the derivative of this function. It's a long process to get there, and in the next video you're going to see how much easier it can be. But I just wanted to demonstrate those 3 types of functions because those are often ones you're going to see and be expected to differentiate using your limit definition or your delta method. So practice some of these, and then when you're ready, let's take a look at the next video.